Okay, so with some very good arguments, you guys have found that this stack has a value of greater than 0 but less than a half because it loses to this stack.
So maybe now we can follow his idea and add 2 of them in.
Okay.
But I'm not too sure what that would do because this is positive.
Right, that's positive.
So, but what would be the inverse of this? Maybe we can try to find the inverse.
Would the inverse be this? Or would it be 2 blues and a red?
Good questions.
Well,
I don't know if the inverse is inversing the blocks or just like reversing the stack.
well, I now have an idea. If we had 2 of these and 1 of these, and if this equals 0, we know what it is.
What would we discover?
We would discover that this is a 4th.
This is a 4th. Okay. And we got to be careful now in doing this analysis. So let's see what we can do here. If this is 0, what's going to happen?
So blue should lose if blue goes first, and red would lose if red goes first. So
Okay.
blue going first. Blue wants to remove this entire stack
Why?
because to get rid of the reds. Because blue doesn't want red to have any turns.
Okay. What choices does blue have if blue goes first?
So blue can remove this top piece,
Okay.
Or blue can
or one of these.
All right. So how many total
So
choices does blue
that's
have?
3 choices.
No, but these 2 are the same choice.
Well,
2
we don't
choices.
have to check that.
Okay. So I don't want you to start by saying blue has to do this because you don't know that blue has to do this. Blue does have 2 other choices. This choice seems to be the same,
Yeah.
but this choice is different.
Maybe we
So you really do want to be careful and don't jump to conclusions. So let's just see what happens here.
So let's start with blue removing this.
Okay.
So then red
Removes this, and then we get back to that scenario that we had before where this is 0 and blue is going to lose.
Okay. So that's interesting. So if blue removes one of the 3 stacks first, blue loses. Okay.
So, what if red? What if
Blue removes this.
Yeah, blue removes that.
then
So-
red? What does red want to do?
Well,
What's red want to do here? Can red force blue to lose? Is what we're trying to find.
So,
Well,
you
wait,
can
if
remove
red-
this or
red
the top
could
one
remove
or
this. Maybe. But if blue removes this, then we don't really know what this is. So, there's a lot of options here.
Yeah.
So, I'm going to start with red removing this and blue removing this.
Okay.
Then,
Then what does red do?
well, just to get it down into a situation we know, this is negative and red will win.
Okay.
So the red can force blue to lose that way.
All right.
And so it's blue's turn here.
Yep.
And if blue removes this,
Then it gets rid of 2 reds.
then it's the same thing. Red is going to win.
Aha.
So now if red removes this one,
Well, but red already found a way to win.
so red doesn't have to do that. So
Yeah.
so red wins if blue removes this. Red is gonna win always. So
If blue goes first.
if blue goes first, red wins.
If blue goes first, red wins. Okay, so we've done a complete analysis because we found a way, if blue removes one of the 3 stacks, we found a way for red to win.
Yeah.
And if blue removes this one, we found a way for red to win. And those are the only 2 starting choices.
Yeah. But what if red goes
What
first?
if red goes first? Maybe
So
this will be more complicated.
Red can either remove this block, or this block.
Okay.
Well, we can. Let's start with red taking away a blue.
Okay, what happens here?
Well,
So then
Oops.
blue.
well, this is positive,
All right.
so blue wins.
So blue wins. Okay, so if red removes that one, blue's going to win. So red's not going to probably want to do that.
So what if red removes the top?
Okay.
Well, it's still positive.
Because
this plus this
they
is
cancel
0.
out, and then there's this
Positive.
plus.
Okay, so if red removes the top of one of the threes, blue
And
wins.
then what if
Red removes the bottom one of the
Okay,
threes.
that's our only choice left.
Blue still wins.
Why?
Because this is negative, and these two are positive, and this is +1.
Ah.
so
So
now we know
this has
that
value 0.
this thing is here, and then so that means this thing times 2 has to equal the positive red blue stack.
So
So
this
it has to
has
equal
value 1/4.
this.
Interesting. So it seemed like it was going to have value 1/3. You may have thought it would have value 1/3. It has 3 cubes. Turns out it has value 1/4.
Interesting.
It's pretty neat.
Yeah.
A lot of analysis to go through that. But we have discovered, starting with just cubes with +1 and -1, we've discovered a stack that has a value of half and a stack that has a value of -1/2.
Yeah.
And now we've discovered a stack that has a value of 1/4. What do you think the stack is that has the value of -1/4?
I think I think it's a red on the bottom and 2 blues on the top.
Okay, and what makes you think that would have a value of -1/4?
Because if you do like
So you mean something like this?
because if you do something like this, it keeps the ratio of the reds and blues the same.
Okay.
But in our other scenario, the ratio of reds to blues was the same as well.
Yeah.
So is it this or this? Is the question.
Yeah. It's interesting. What do you guess? Let's maybe we'll talk about that tomorrow. What do you guess? Which one do you think?
I'm gonna guess this one.
Okay.
I think that one.
Okay. Well, maybe tomorrow we'll see.
Okay.
All right. Good work this morning, guys.